Imagine you're holding a grain of sand in your hand. It feels tiny, right? Now imagine shrinking, smoothly, continuously, like a video game zoom slider that never stops. And you keep going. The terrifying truth is, small doesn't really have a bottom that your brain can picture. Not in any normal way. Today we're doing the opposite of infinite space. We're diving into infinite small, how tiny things can get. What the world looks like as you shrink past insects, past cells, past DNA, into atoms, and then into a place where the universe stops acting like a solid reality and starts acting like math. So let's start at a size you can actually feel. A human hair is about 70 micrometers thick. That's 70 millionths of a meter. If you lay a human hair next to a speck of dust, the dust can look like a boulder. And already we're at a scale where your eyes are basically guessing. Now shrink down until you're standing on your own fingertip. Your skin isn't smooth, it's a landscape. Ridges, valleys, cracks. You'd see flakes of dead skin like giant plates peeling off. You'd see pores like caves. If your finger were a planet, the surface would look rougher than a mountain range. Zoom in again, and you start seeing the real residents of your body, cells. Your body has around 30 to 40 trillion cells, depending on the estimate. And almost none of them look like the perfect circle cell you saw in textbooks. Some are long cables, some are branching trees, some are weird blobs that change shape like living slime. Red blood cells are about 7 to 8 micrometers across. They don't have nuclei. They're basically flexible oxygen delivery trucks designed to squeeze through tiny capillaries that are so narrow they have to fold like tacos to fit. And your brain? Your brain is a city made of cells. Neurons can be microscopic, but some of them are so long they stretch from your spine to your toes. Imagine one cell that's basically the length of a human. Biology is insane. Now let's shrink more, past cells, to the machines inside them. Inside most cells, you'll find a nucleus, like a vault, and inside that vault is DNA. Here's a fact that sounds fake. If you unraveled all the DNA in your body and laid it end to end, it would reach ridiculous distances, so far that the number becomes hard to even use in conversation. But what matters is this. Your DNA is packed so tightly inside nuclei that are microscopic. It's like stuffing kilometers of thread into something smaller than a dust speck. And DNA isn't just information. It's physical. It's a molecule. It's a spiral ladder made of atoms, and it gets copied, repaired, folded, and used like code by proteins that act like tiny biological robots. Now zoom out for a second to something you can visualize. Insects. If you've ever looked at an ant up close, you've seen a creature that's small but still big compared to the world we're about to enter. An ant can lift multiple times its own body weight because of something called the square cube law. As you get smaller, volume and mass shrink faster than strength-related cross-sectional area. In simple terms, small creatures are, in some ways, built like superheroes. Gravity is less of a problem when you're tiny, but shrinking isn't just about scale. It changes what the world is made of, because once you go past insects, past cells, past molecules, you reach the level where solid stops being what you think it is. You reach atoms. An atom is absurdly small, about 1/10 of a nanometer for the basic size scale, depending on what you mean by size. A nanometer is 1/1000th of a meter. If a meter were the Earth, a nanometer would be roughly the size of a marble. That's the vibe. But here's the weirder part. Atoms are mostly empty space. If you expanded an atom until it was the size of a football stadium, the nucleus would be like a tiny bead somewhere near the center. The electrons aren't little planets orbiting like the solar system either. They're more like a probability cloud, regions where the electron is likely to be found if you measure it. So when you touch a table, your hand isn't pressing against solid wood in the way your brain imagines. It's electromagnetic forces. It's your atoms and the table's atoms repelling each other because their electron clouds don't want to overlap. You're not touching the table like two solid objects. You're hovering on force fields. Now let's go smaller than atoms, because yes, they're smaller. Inside the nucleus, you find protons and neutrons, and inside those, quarks. Quarks are one of the smallest things we can talk about with confidence. They're like the building blocks of protons and neutrons, held together by something called the strong force, carried by particles called gluons. And unlike magnets, The strong force gets stronger when you try to pull quarks apart. It's like reality has a built-in anti-escape system. And at this scale, the universe is not behaving like the world you grew up in. At the quantum level, things don't have exact positions and velocities at the same time. The act of measuring matters. Particles can behave like waves. Two particles can become entangled so that measuring one instantly tells you something about the other, no matter how far apart they are. This isn't science fiction. This is the normal operating system of the universe. Now the real question, can we keep going forever? Is there an infinitely small? The same way there might be infinite space. Here's the honest answer. We don't know, but we do have a famous candidate for a smallest meaningful scale, the Planck length. The Planck length is around 1.6 times 10 to the minus 35 meters. That's a decimal so tiny, it's basically a joke to human intuition. It's the scale where our current physics starts to break down, where quantum mechanics and gravity both become important at the same time, and we don't have a complete theory that merges them perfectly. It doesn't necessarily mean nothing smaller exists. It might mean that smaller distances stop making physical sense in the way we understand distance, like zooming in past the pixel limit of reality. And if you want a mental image, some ideas suggest that space at that scale could be quantized, like it comes in tiny chunks. Others suggest it could be foamy, fluctuating, unstable, like the universe is bubbling at the smallest levels. But nobody can say for sure yet, because we don't currently have experiments that can directly probe that scale. So what happens if you keep shrinking, conceptually? You pass objects you recognize, into systems you don't, into rules that start to feel like pure math. And that brings us back to the human body, because it's the perfect reminder of how insane tiny scales really are. Inside you right now, there are cells dividing, proteins folding, electrical signals firing, bacteria living on your skin and in your gut, and molecules colliding like trillions of microscopic billiard balls. There are machines inside your cells that literally walk along strands, carrying cargo. There are tiny motors that spin. There are chemical factories that assemble and disassemble parts, constantly. You're not just a person, you're a universe of small things, cooperating long enough to call themselves you. And the wildest part is, you never directly experience any of it. Your brain experiences a simplified story, solid objects, smooth surfaces, continuous motion. But underneath that story is a layered reality. Cells, molecules, atoms, quarks, fields, probabilities, rules stacked on rules. So how small can things get? We can confidently go down to atoms, to nuclei, to quarks, to quantum fields. Beyond that, we enter the frontier, where we suspect something like a limit exists, but we don't know whether it's a hard wall or just a sign that we need better physics. And that might be the most mind-blowing part of the infinitely small idea. The universe may not have a smallest thing. It may have a smallest meaningful question, because at some point, smaller might stop being a place you can go and become a concept that no longer fits inside the universe's rules. So the next time you look at an ant, or a speck of dust floating in sunlight, or the ridges of your fingerprint, remember, that's not small, that's a doorway. And if you zoom in far enough, the world doesn't become simpler. It becomes stranger than space. Because when you go infinitely small, you don't just find smaller things, you find the code reality is running on.